Hello, welcome to Lesson 18 of Mastering Java. I'm Jason with CodeLearner.com. Here we're going to continue working with variable types or data types. We have learned in the previous several lessons, all the way up until we started first writing code, that the most common type of variable that we're going to use for whole numbers is going to be the integer type. And I believe I even told you that the range of the integer type in Java is this one here highlighted, a very large range of numbers from -2 billion, 147 million, blah, 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 up to +2 billion, blah, blah, blah. So for the great vast majority of cases, if you need to have a whole number in your program, for whatever reason, just declare it as an integer because it's 32 bits, it's a huge range of numbers, and it is very likely going to suit your needs perfectly for almost every application. However, Java does provide other types of integers, and these are here, and I'll show you what they are. Well, another type of integer is called a byte, and you would guess that a byte consists of 8 bits, and so the range of that would be -128 to +127. So if, for instance, you were writing a program and you knew for a fact that the variable that you had and that you plan to use through all branches of your program would never get bigger than this range, then you could declare it as a byte and it would only take 8 bits of memory. So if you were really programming for a situation where you were trying to minimize the amount of memory your program was taking, then it might be a good choice to choose a byte here. However, most modern computers have so much memory this is not a concern, but still, if you were programming for some embedded device or for some portable device, it might be useful. You also have the choice of declaring as a short variable. This one is 16 bits, and it is a range of -32,000 and some change up to +32,000 and some change. So this could be useful if, for instance, you're trying to save on memory and you know that your variable is going to fall between this range and so on. Now we've already talked about integers, which are 32 bits in Java, and they have this very large range. That's what you're mostly going to be using. And then of course we have something even bigger than the typical integer, which is 64 bits and has an enormous range. I can't even say this number out loud, it's so big. So it's just a huge number, negative all the way up to positive. So these would be used in times, longs would be used in times when you were doing calculations with very big numbers or very large negative numbers. Like, for instance, if you were calculating the distance between planets or something like that, where you were going to have a lot of digits that were falling outside of the range of a regular integer, then you might need to use a long. All right, so that is really all of the different integer types of variables in Java. But I want to stress before we get into a little example here, I want to stress a couple of things. The first thing I want to stress is 99.999% of the time you're going to just use an integer. So most of this lesson, I don't want to say that you can just discard it because it would be useful information for you, but most of the time, especially in the beginning, if you have use for a whole number in your code, just declare it as an integer. It's going to get you by with 99% of the cases. You only use these two if you're trying to save memory, and you only use this one if you have gargantuan numbers that you know you're going to be dealing with. Most of the time, just use an integer. Second thing I want to tell you is there are some gotchas with some of this stuff, and I'll show you what they are down here. So let's just kind of get right to the chase here. Let's say I wanted to declare a byte type of variable, so I just type the byte keyword. Notice that it changes to purple. And let's say I'm going to call it byte variable, like this. So, byte variable. So, byte, notice I'm starting my variable with a lowercase, and the next word I've capitalized, and this is typically how you want to name your variables in Java. All right, now let's initialize it, and let's start it off at a value of 100. So here, we know that this 100 is inside of the range allowable by a byte. So even though I'm not really doing anything, I'm not printing anything, it doesn't seem to give me any big errors, and when I run it, even though there's no output, it seems to have run okay. The only reason it didn't output anything is because I didn't put a print statement anywhere. But this seems to have worked. Now let's see what happens if I change this, and I change this to 135. This is outside the bounds of really what a byte is allowed to do. Notice that Eclipse has underlined it. Let me go ahead and save it. If I try to run it, it's going to throw up an error and say, hey, there's an error. Do you want to do this anyway? And you can try if you want, but it's basically not going to work right. If you hover over this, notice it says type mismatch, cannot convert from int to byte. Now, I want to explain what this means. In Java. In Java, whenever you type numbers in, forget about the left-hand side here. Here we've typed a number in, 135. Typically when you type a number in, Java is going to sort of assume it's an integer unless you tell it otherwise. So this 135 is really an integer. And when you try to store it into a byte variable, it tries to convert that integer into the byte format, which is a fewer number of bits. All right? And the error is telling you it can't do that. It can't convert this number from an integer to a byte because it's too big, basically. It won't fit into the byte variable, so it's throwing up that warning. Back a minute ago when we had 100 here, Java was interpreting this as an integer, and then whenever it stores it in here, it converts it down to a byte. And since this number is small enough to fit inside of the byte, there are no errors and no warnings, and it all worked transparently. So I guess what I'm trying to say is if you try to put a very big number in here, negative or positive, that won't fit, if you get something underlined, even no matter what it says cannot convert int to byte, just note that what that means is it's basically too big. It's not going to work. All right, so let's go ahead and set this back into a range of something we know we can put in there. And let's move on to the next variable, short. If you wanted to declare a short variable, we can call it short variable like this. And I can set this equal to, 32,000 even. All right. Now this will fit fine because the range of a short variable is negative to positive 32,000 and some change, so this fits in there just fine. But again, whenever I type this number in, this is called a literal. Whenever I type a number into Java, like a constant or something, it's called a literal, and Java has to interpret it some sort of way, so it assumes it's an integer. When you type numbers in, whole numbers like this, it assumes it's an integer, and whenever it tries to store it into this short variable, it converts it to a short, and it basically chops away a lot of bits, putting it into a 16-bit format. And since this number is small enough to fit, everything works fine. But if I try to go up to 40,000, for instance, that's outside the range allowable, and so when you hover over it, it says cannot convert from int to short. It's a cryptic message if you don't know what it's saying. What it's saying is Java is trying to convert this integer that you've typed in into a short, and it's not working because it's just out of bounds. So that, again, if you see red squiggly underlines, that means you've made a mistake. So let's put this as negative 2,000 or something that we know fits in range, and you see everything goes away. Now we've already talked about integer variables. We've already done that, and let's call this one int variable, and let's assign that one equal to 100,000. And this works fine because, again, on the right-hand side I've typed in a number, which is an integer. And since what's on the right-hand side is an integer, and what we're trying to store it into is an integer, there's no conversion that needs to be done, so everything's fine. But if you try to put something too big here, let's just start sticking a bunch of numbers in here, and click off of it, notice we've underlined it, and now it doesn't say that it has a problem converting. It says the literal, and it tells you what it is, of type int is out of range. It doesn't tell you there's a problem converting because it's not trying to convert anything. When you type this number in, it assumes it's an integer. You're trying to put it into an integer variable. The types match. It's just that this number is basically bigger than can fit inside of an integer. And so there's a problem there. So again, if you see red squiggly underlines under your numbers, that's a problem. So let's go ahead and take this out and put it into a form where there's no errors. And finally, let's go to our friend, the long variable, which is long variable, right? And let's put a number, 500,000 in there, right? And again, this is working fine because this is an integer, and then whenever we type numbers in here, it's an integer, and it's trying to convert it into a long variable, but which is fine. It's totally within the realm or the range of it, so it's all going to work fine. But let's see what happens when we add a bunch of digits. So here we have, notice in our numbers up here, we have 1, 2, 3, 4, 5, 6 set of 3s. So here's 1, 2, 3, 4, 5. So it's 5 sets of 3. This number seems to be perfectly within the range of the long that we have here. But again, it says the literal of type int is out of range. And this makes no sense at first glance because, first of all, this is not an int variable. What is it saying? Again, when you type numbers into just code like this, it's called a literal. That's why when you hover over it, it refers to the literal, right? So this is automatically going to be assumed to be an integer. It's the same as it was up here. This was an integer that it's trying to store in a byte, and if it needs to convert, it will. this is an integer that is trying to store in the short variable. It'll convert if it needs to. This is an integer over here. Of course, it's going into an integer variable. And this is an integer that's trying to be stored into a long variable, but it's giving us a problem. It's telling us it's out of range, and we know that it's not. The problem is not that it's out of bounds in this range. The problem is that this is an integer on the right-hand side, and the integer on the right-hand side, because we've typed a number, is outside of the range of what integers can be, which is this. So that's a long-winded way of saying that we need to tell Java that this number over here, stop trying to treat it as an integer, treat it as a long. And the way you do that is you put an L at the end of it, and notice everything disappears. So now it tells me that this variable here is now going to be treated as a long, not as an integer, as a long, and that's going to be stored into the long variable that we have defined right here. So now if we go to system.out.println like this, and then we just put the variable long variable, let's just print the variable by itself. We'll put a semicolon at the end, we'll hit save. Then what gets printed out here is exactly what we expect. If we take the L away, like this, there's a problem, and then things are not going to be working right now. You can use a lowercase l or you can use an uppercase L. Basically, you can put an L next to a literal, which is a number that you type in, if you know and you're trying to tell Java to treat it as a long. So this is typically done whenever you're initializing long variables. It's something you see a lot. All right. Now let's go here, and let's under this guy, under this print statement here, let's say long variable equals long variable plus 1, like this. And then let's go to system.out.println like this, and let's do long variable like this. We'll go ahead and hit save. We'll print, and notice that we've added 1 to it, and then we've incremented, because in this calculation statement here, what we have done is we said, hey, this is a long. It's declared as a long. What's stored into it is a long. We're adding 1 to it. So if you really think about it, this number 1 is an integer. It's going to be treated as an integer in Java. This is a long, but whenever you have mixed types like this, Java's pretty smart. It knows, hey, this is a long variable, this is a little tiny integer here, we're going to add them up, we're going to treat the result as long, stored in this variable so that everything works just fine. So this is kind of a long-winded explanation for a pretty simple concept. I just want to make sure you understand the different types of integers available to you in Java, but again, talking about some of the gotchas here. To summarize, 99.9% of the time, if you need a whole number, just use integer. All the default numbers you type in are going to be assumed to be integers. All of the adding and subtracting, multiplying, dividing are all going to be done in terms of integers, so just use integers. If you really have large numbers, declare them as long, but just be aware that when you store numbers into them, you need to tell Java to treat the numbers as long whenever you make the initialization, right? And if you have occasion or need to use smaller data types, which would only be done if you're trying to save memory, if you're programming for an embedded device or like a pocket calculator, wristwatch, something that doesn't have a lot of memory, then you can do that, but you just need to be aware of the size of the data types and keep track of all that stuff as you're doing your programming, because that's going to become critical for you. And we showed a few times when you're trying to make those assignments how sometimes you can get errors thrown up when you're not in range. But the takeaway is use integer whenever you can, because that is really the default integer type within Java, and it's the one that's going to be used most frequently and the one that you're going to be able to use in 99% of your programming.